In this video, we'll be talking about properties of matter. So a property is a characteristic that enables us to distinguish one kind of matter from another. So it's what you think it is. A property is something that helps you identify an object. Like this powder over here, we'd say it's a fine blue powder. This fact that we're saying fine is a property, a description of it. It's blue, that's another property of it. So that's all we mean by property. There are ways to identify characteristics of matter to distinguish one from another. Now, a physical property can be observed or measured without altering the identity of that material. So, an example is length. If I want to measure the length of this pencil, I'm not destroying the pencil when I measure it, so that's a physical property. Same thing with this blue powder over here. By identifying it as blue, that doesn't change what it's made of. I'm just identifying it, and it's not changing anything. So that's a physical property. So examples, length, mass, color, texture, those are physical properties. Now we can break physical properties into extensive or intensive physical properties. Now the word extensive means that it depends on how much is present. So in the example above, length would be an extensive physical property. So the length of this pencil is extensive. If I sharpen this pencil, there's going to be less pencil there and it's going to have a different length. So the length depends on how much pencil is left over. So extensive depends on how much is there. Mass, volume, weight. If I have a bigger sample of something, it's going to take up a bigger volume. It's going to have more weight, more mass. Now, intensive properties do not depend on the amount of matter present. So examples are texture, color, density, and boiling point. So going back to this, if I have even the smallest little bit of this powder, it's still blue. If I have a lot of it, it's still blue. It doesn't matter how much of this powder I have, this powder is inherently blue. That's an intensive property. It doesn't matter how much powder I have, it's blue. But if I have more powder, I'm going to have more mass, more weight. So that would be extensive. So that's the difference between intensive and extensive. So check for understanding. You can do this on your own. We will do this in class, so I will not give you the answers here, but try it on your own. Now, a chemical property predicts how a chemical will react. So is it going to react with oxygen, with water, with an acid, with a base? Will it react violently, slowly? How is it going to react? That's a chemical property. So examples are flammability, will it set on fire, acidity, basicity, combustibility, reactivity. Combustibility is similar to flammability, will it burn in the presence of oxygen. And all properties that are chemical properties are intensive. So you don't have to, if it's chemical, you don't have to say whether it's intensive or extensive. It will always be intensive. Now, changes in matter. A physical change is when the material changes without actually changing the identity of it, or the chemical makeup of it. So you'll have the same material before as after is before. Nothing changes chemically. So examples: cutting, bending, grinding, splitting, freezing, boiling. So if I dissolve salt in water, there's still salt and there's still water. I haven't actually changed anything chemically, but they have changed physically, right? They look different. Same thing if I tear a piece of paper in half. That piece of paper, it's still a piece of paper. No chemical reaction happened. But now you have two smaller sheets of paper, so you changed the physical size of the paper. That's a physical change. And then phase changes are physical. Phase changes are physical. So if I take liquid water, I cool it down till it turns into ice. That's freezing. The ice looks different, but it's still made of H2O. So its chemical composition is still the same. So any phase changes, boiling water, freezing water, anything like that is physical. Changes in matter. A chemical change, sorry, I don't know why I read the top there. A chemical change is different from a physical change because you'll end up with a new material. The identity will change. A chemical reaction must happen for a chemical change to occur. So you got a new identity. So you might start with A plus B as an example, and it turns into C. So you end up with a new substance. So we got an example here. So this is how you write out a chemical reaction. Reactants start on the left side. Products are always on the right side. You should remember these terms, reactants and products. Reactants are what you start with. This is what you end with. An example would be like cooking. Your reactants are your ingredient. If you're baking a cake, you might put sugar, flour, baking soda, eggs, whatever other ingredients you put into a cake. You put those together, you mix them together. When you're stirring them together, making the cake better, that's all physical changes. Nothing has chemically changed yet. You're just mixing them physically. But then when you put it in the oven and add heat, the compounds that are mixed together, they chemically combine with each other to make a new substance, and that new substance, the product, would be the cake. So the ingredients are your reactants, the cake would be your product. Here's an example of a chemical reaction. You've got sodium metal plus chlorine gas turns into sodium chloride, which is table salt. And to illustrate the idea that you end up with a new substance, I always like to use this example because sodium metal, this metal will react violently with water. That's why it's always stored in oil or like kerosene. It'll fizz and give off a lot of heat, give off a lot of hydrogen gas, potentially even start on fire. Chlorine gas is a dense green gas that's very toxic to humans. Was even used in chemical warfare in the early 1900s for one of the world wars. But when you mix them, they'll chemically combine to form a completely new substance that's called table salt, which you sprinkle on your food. So both very dangerous substances combine to form something with completely new identity and completely new properties because there's a chemical reaction that happens. This doesn't resemble either of these things at all. And it's even edible. So you can see the difference there. So that's a chemical reaction. So this would be a chemical change. You have a new substance formed. And here is a quick little video of the chlorine and the sodium reacting. You can see it's a very violent reaction as well. You'd end up with table salt. This is actually not where your table salt comes from, though. Chemists don't sit in a lab and do this all day to make the salt that you get in the grocery store. It would be most likely mined or evaporated from seawater to get the salt that you eat. But this is just an example of a chemical reaction. So you need to know the difference between physical and chemical changes, physical and chemical properties, and make sure if it's physical, you can tell if it's intensive or extensive. So there's a lot of little things. Make sure you know each of those. Again, physical, intensive, or extensive, chemical properties, and the difference between physical or a chemical change.